Shinkansen, so we will move back to Shinkansen. So when I arrived at the airport, as usual, after 65 years of teaching students, the students always like to ask me questions. One question they ask me, what research am I doing at the moment? And my answer is, what do you want me to do? In other words, people come from pharmacy, from food science, giving problem to us. When they give problem, we try to help them. And one of the problems is the pharmacies, when they do drug formulation, they have problem, solubility of the active agent, stability. So we design some compounds to help them to maintain solubility, stability, compatibility, etc. So one of the compounds is, I'm talking about this afternoon, is ethylene-diammonium dicarboxylate, salt and co-crystallization for biological and pharmaceutical application, right? Okay, next slide. So what I'm doing is trying to react an amine compound with diprotic acid. When I say diprotic acid, we have two acidic groups like oxalic acid, palmaric acid, adipic acid, succinic acid, and also azelaic acid. Okay. So we have two acidic groups which can be deprotonated. The first one is governed by pKa1, and again deprotonated, you have pKa2. That will determine the mode of reaction with your ethylene-diamine. Of course, my students have been working not only with ethylene-diamine, with some other amine compounds. So I'm talking only about ethylene-diamine. Okay, next slide. Next slide. Okay, so as I told you, soft formation is a strategy in pharmaceutical industry in order to modify the property of the drug. So this is one of the purpose, one of the application. Next slide. So what we did was, we mixed many reactions and tried to determine what are the products, what are the formula of the compound. And that is not an easy job. So I summarize you the formula after we have done all the work. Then you will ask me, how did you get this formula? That is a challenge for a chemist to do. The pharmacists, the food technologists, I want these products. I don't want to buy from the market. It's it's very expensive. So they want chemists to do it. So we'll do it for you. It's good for us. You've got a problem, you give us, we work together, okay? So don't ask me now. I will show you how we do this analysis. Next slide. Okay. For a chemist, when you got products, one method is the CHN analysis. A chemist, we always tell, don't simply do things, but you think about the thing. Think. And then your expectation. And then you determine the carbon, hydrogen, oxygen percentages. Try to match with what you expected. In most cases, it don't. In some cases, it matches. Okay? This is CHN analysis, very common for the chemist. And you measure the molar conductivity, then you know whether it is ionic in solution or not. Many pharmacies, they want ionic, so it's soluble in water. Next slide. And then you have infrared spectroscopy. I will go very fast because I'm sitting in the Shinkansen now. So you look for the functional group. If there is functional group that match to your expectation, okay, you prove there is a functional group in your compound. Next slide. You do UV, try to determine the peak, try to determine the chromophore, and the excitation energy. Next slide. You do NMR, try to assign all the proton NMR, carbon 13 NMR within your expected structures. Okay? NMR. Next slide. Then we do X-ray crystallography. The students always enjoy X-ray crystallography, even though they do not know what is crystal. If I ask you what is crystal, do you know crystal? Yes. What is it? I don't know. Very common answer. Okay. If you go to the mountain, to the rock, you see a lot of crystals. But you'll find in Iran, they sold the sugar crystal, so they eat crystal, you know. So one of my students from Iran came back and brought some sweet candy, all sugar crystals. So they sell in the form of crystal. Next slide. Ladies like crystal. When ladies see all beautiful crystal, they like crystal. They make ring, etc., etc. But yet you ask them what is crystal, they will not be able to answer unless they come for a course. What crystal, how crystal is built, how crystal is assembled, etc., etc. Next slide. Yeah. So when you learn X-ray crystallography, you are making use of the X-ray light to the crystal. The light will be scattered, and this scattering light can be used to study the molecular structure. That is called X-ray crystallography. Now it's called X-ray chemical crystallography. Next slide. Okay. It's not an easy job. For crystallography, you must use very small crystal, 5 mm size. And students got problem to choose one amount. Only old men like me manage to mount the crystal on the fiber. Okay, next slide. This is not a single crystal, this is XRD, but my machine is next to the machine. Now this is a crystal that you mounted on the fiber. It's very small. So you align so that the X-ray will pass through the crystal all the time. Then you rotate. Okay, next slide. This is another way of making crystal. This is a metal compound crystal. You hang it on a ring. So you rotate so that the X-ray will hit the crystal. Okay, next slide. This is what you observe. You observe reflection. From the reflection, you use your software to solve the structure, and you end up with, next slide, some good structures. So just simple introduction about X-ray crystallography. Alright? So when you got all the products, the ethylene diamine, oxalate, ethylene diamine, you mix with something else, hoping that it will crystallize together. What we found is, so this is ethylene diamine, and this is thiocyanate. Okay? Thiocyanate is ambidentate species, meaning it can coordinate through nitrogen, it can also coordinate through sulfur. Okay? Either one, or both, when they compete with the metal. So this is the best way, everybody like it, but the problem is to make crystal. Some people go no light, after 1 year, no crystal. So when they ask me which one you prefer, I like the one which have light. Everybody go intelligent, sometimes go no light. Okay? Okay. This is ethylene diaminium with the thiocyanate, no oxalate. Doesn't come into the product. Okay, next slide. Here, in the different conditions, I get my oxalate into the ethylene diaminium together with the thiocyanate. How do it? You ask my student. I will tell you at the moment. Don't worry about how to do it. It's just varying the pH. Okay, next slide. Yeah, okay. This is ethylene diaminium, and this is succinate. Okay? So we get crystal, you study the structure, this will support your chemical analysis data. But mind you, X-ray crystallography is not a chemical analysis. It is a modeling that made with the X-ray reflection. The less the difference, the better your result. Okay, next slide. So I summarize, when you do X-ray crystallography, you have to determine the unit cell, the system, monoclinic, cubic, etc. You end up with the molecular structures. Alright? Next slide. One advantage is the molecules in the solid state are arranged in an orderly manner. That's why you call it crystal. And some of the molecules, they are linked together by hydrogen bonds. But in solution, the behavior may be different. But in solid state, they are linked by hydrogen bond with so many patterns, 3-dimensional, 2-dimensional, form network, etc. You can get this information from X-ray crystallography. Next slide. Okay, another unique thing is that this time it doesn't form the ionic salt. It is a base shift, meaning your carboxylate, one of the oxygen here, form a phase shift to the carbon. So this again the beauty of a chemical reaction. I'm going very fast.
1 minute, Chair.
Okay.
Sure.
One more? 1 minute?
1 minute, Chair.
Okay. Next slide. So we can make a conclusion on the reaction. Next slide. We study the antibacterial. Some of them show antibacterial, some of them don't. We study the cytotoxicity with the people from biochemistry. Next slide. These are the cytotoxicity. They are very low, meaning safe. Okay, next slide. We can make conclusion. We have prepared more than 90 ammonium salt with diprotic acid. Study the bacteria, study the cytotoxicity, other property as well. So next slide, before I stop, I must acknowledge, I must remind, don't forget to acknowledge people wherever you visit. My university will give you the money, the ministry will give the money, etc. Next slide. This is my research group. You can see now in Japan, many men, in Malaysia, many women. My friend in Japan said, can we exchange? This is my research group, my young staff there, they are here. Farooq and Shah. Next slide. This is my grandchildren. Okay, 10 of them. Next slide. This is 3 on the right. Is from Bukit Tinggi. So I got 3 grandchildren. The father came from Bukit Tinggi. You can see their faces. I mean, Minangkabau faces. Next slide. This is my wife. We grow kangkung, but she likes to pick up kangkung. Alright. Next slide. Thank you very much and jumpa lagi.
Would you like to take it? Thank you. I have a question for you.
Yeah, okay.
Can you make a crystal ball for predict my future? Crystal ball.
Okay. Okay, I play football.
The second